So 4.4 is simplifying algebraic expressions involving exponents. So the other sections that we did had a lot of calculating. We were evaluating, we were simplifying as far as possible, we were adding those things together. So this one here, look, we've got bases that have variables now. Right, so we've got some nice little variables. So you can see that we're going to mix it up. And look, we've got numbers, right, coefficients. And look, we've got 27 with the 1/3 with bases. So that's what they're saying. The algebraic word that they're talking about is that there's going to be more variables. Okay, so that's why we're changing it up. So instead of the bases just being numbers, which we were looking at before, now the bases are variables. So that's why it's algebraic, right? So a little bit more of that algebra happening. What we have here is we have 2x to the negative 3, y squared all to the power of 3, and we have x to the power of 3, y to the negative 4 squared. My advice to you is, you don't have to do this, but please imagine that 2 has the exponent of what? What's the exponent of the 2? I'm going to zoom in again. 1. It has its own exponent. It always gets forgotten. So anytime we have a number attached to a variable, people tend to forget it, and they think that 2 also has the exponent of negative 3. Can you see that 2 does not have the exponent of negative 3? If I wanted 2 to have the exponent of negative 3, what would I have to do? I would have to do this. Grab it, right? So that would mean the 2 also has it. But do you see how there's no bracket around it? So the exponent of the 2 is actually 1. You don't have to put it, but that's what you're imagining. Right? So put it for a placeholder now if you need to, and then eventually you won't do that. But imagine that 2 has its own exponent. It does not have, if I wanted it, I would put it in a bracket. You see the difference? All right, so this one has not touching the negative 3. This one has a bracket around it. Okay, so based on that, that means that this is the power rule. So here we can use the exponent laws. So the exponent laws first. We're not evaluating till we finish doing the exponent laws. The exponent laws are when we have power to a power, so power, right? When we multiply or when we divide. So that's when we use these exponent laws. We use the exponent laws when we have a power to a power, multiply or divide. This is a power to power. When we do this, we are going to multiply. Does that make sense? So we're going to multiply in. We're going to do multiply, multiply, multiply. All 3 of those get multiplied by the 3 on the outside. So we're doing exponent laws. Same thing for the denominator. There's no coefficient in front, so it's just going to be x, and then we do this, and it's still multiplication. Right? So power to a power means we multiply. You don't have to do these symbols. That's for our notes. Okay, is that zoomed in enough? We've got that. So we're going to go 2. 2 also gets the power of 3. Everyone always forgets. They go, yeah, 2's sitting in front. But it gets 2 of the 3's. If it was just, if I'd given you this, you go, oh yeah, of course, that's 2 to the 3. But once I attach it, people forget and they just go x to the 3, but it's also 2 to the 3 as well. Right? It's 2x times 2x times 2x 3 times. So there's 3 2's and there's 3 x's. For some reason, when it's attached to the variable kind of overshadows the number, the coefficient, and you guys forget it. So that's why I'm like, remember, it's got its own power. So each one of them. Right? So that's what this is happening, is that 2 has its own power, and then x to the negative 9 and y to the 6. And then here on the bottom, power to power means you multiply. X to the 6, y to the negative 8. Okay, so now you have 2 choices. What I do not want happening is I don't want to create a fraction on a fraction. So I don't want to see this. That's crazy, because then you've got now fractions. Look, see how awful that looks? You go, wait, I've never seen anything look like all messy like this. It's got fractions on fractions. I don't want to do that. Yeah.
Can't you just swap like the -8 and the
Yes, exactly. This -9. So the ones with the negative, we're going to swap them. So if it's a negative on the top, this is the beginning of the chapter theory with the negatives. This one and this one move. Everyone else stays still. So this one has its own power. It has the power of 3. You can rewrite it as 8 if you want. So that's okay to evaluate that. The two yellow ones are negative, and negative we learned at the beginning of this chapter that if it's a negative on the top, we move it to the bottom. If it's a negative on the bottom, we move it to the top. So I'm going to move it. I can leave the y to the 6 and move the y to the 8 up, and then I'm going to leave the x to the 6, and I'm going to move the x to the 9 to the bottom, right? So these guys here moved. Doesn't matter the order. You could have put it in front or beside, because now what happens? You have a y to the 6 and a y to the 8. When you are multiplying, you add the exponents. So now I'm going to add these two exponents. So these symbols here I'm putting on the side are just so you know what I was doing. I'm adding them. And I'm going to get 8 on the top, doesn't move, y to the 14, and x to the 15. And I didn't have to flip anything, right? I was just moving them from the numerator to denominator. No fraction on a fraction. It doesn't look super complicated, right? So when things start to get really complicated, you go, wait, am I doing this in a bad way? Is this the wrong way to do it? Okay, you kind of go, oh, maybe I'm doing it in the worst way. So here, that was just moving it from top to bottom. That was one of the first theories we learned on the first day. Yeah.
Can't you just subtract?
Yes. So there's two different ways to do it. This is this way. The other way to do it is you can do subtraction. So we know that this is division, which means subtraction. So you can go -9 minus 8. So that would get me, so I'm going to do an or. Don't do both answers. But from here, I could have done subtraction. So I would still have gotten the 8. But if I go -9 minus 6, I would go x to the -15. And then here, I go 6 minus 8, that would be 14. So if I do subtraction, so this is subtraction. So I'll show you, this one I did -9 minus 6, and this one I did 6 minus -8. Again, that's just your brain thinking that. But then you go nothing's on the bottom. So then I take away the denominator, and I go, okay, but nothing's in the denominator, right? It's all gone. I moved it all up to the top. Okay, but then your answer, okay, this is very important. This is the same answer. Whenever we ask for this from grade 11 to grade 12, we will ask you to write your answer with positive, so answer with positive exponents. Okay? Always I want you to answer with a positive exponent. That means on your very final step, you take a look and go, wait, this is good, but I have a -15, so now you're going to do that shift to the bottom thing. Okay, so you're going to leave the 8 on the top. You're going to leave the y to the 14 on the top because it's positive, and the only one that moves is this one here because it's got the negative. So that one moves to the bottom, and it becomes x to the 15 on the bottom. Okay, and look, they're the same. So with exponent laws, these exponent laws, there's going to be different orders that we can do it in. Anytime we did exponent stuff, there's going to be more than one answer. So a lot of the questions will have an or possibility, subtraction, or by shifting, and then by adding. So there will be some or scenarios. As long as you're doing things mathematically correct, you should get the same answer. Okay, so both of those are good. Let's try it again. So we're going to try a few more. Okay, this one here, I'm starting, so this you can see I've got negatives, right? So negatives, we started this before in grade 9, but we never had like double powers like this. This was way longer than we did. We had maybe just one set, right? So now we're doing longer questions. We never had fractions. So for this one here, I'm going to rewrite the question. And I don't like it in the root form. I'd rather have it in the fraction form. I can write it under, but look, I'm running out of room here, so I'm going to go beside, and then I'll do a column heading down. Okay, and you're allowed to do that. So you can go to the side. So if I run out of room here, I'm going to go to the side, and then I'm going to use my column heading down. So see this 8 and the root 5? I'm going to rewrite that as x. The 8 goes on top, and this root here, that root there, goes on the bottom. So that goes on the bottom, so it's over 5. So this root always goes on the bottom. Does that make sense? Right, we learned how to write it backwards and forwards the other day. Okay, so I just rewrote it. I'll keep the 3 on the outside, so I'll do this. I'll keep that for later. So that's the 3 here. Okay, for the bottom, can you rewrite that as a fraction? I find it easier to subtract fractions. How do we do that then? 3 over 2, good. There's an invisible 2, right? That's an invisible 2, so that's the invisible 2 here. Does that make sense? Invisible 2. Don't write the 2, we know it's an invisible 2. Okay, so now there's nothing to calculate because there's no numbers, but we can definitely keep going with division becomes subtract, like use the exponent laws. Division becomes subtraction. So I can finish all the inside and then multiply by 3, or I can, so look, a lot of these are going to have different orders of the answer. So I can multiply each one by 3, power to power, or I can subtract and then multiply by 3. Which would you like to do? Subtract first and then multiply by 3? Yeah, let's do that because then multiply by 3 is going to get bigger. I'll do that. But you can do it the other order. You should get the same answer. So let's do subtraction. So here I'm going to do x. I'm going to do the subtraction on the side. So I'm going to pull it to the side, and I'm going to go over here on the side. I'm going to go 8 over 5 minus 3 over 2. So you're always welcome to do this on the rough paper. So this is my bubble. That's my brain on the rough paper. I'm going to do lowest common. So there'll be 2, 10, right? So that's 16 minus 15. You can go faster. I realize some of you are going faster. So 16 minus 15, so it'll be 1 over 10. You take that number and you put it in here. So 1 over 10. You don't have to show me the bubble. The bubble's on the rough paper, and you're just putting the 1 over 10 there. So I'm going top. Remember, we always read from the top to the bottom. So go 8 over 5 minus 3 over 2. Top minus the bottom. This way. Okay? Then I still have the 3 on the outside, don't I? Didn't do it. So I did exponent law with the division first. Then now power to power means you, easy, multiply, right? But then I put this over 1. So I usually do an over 1. Does that make sense? So over 1. And I do top times top, bottom times bottom. So I'm going to get x, and numerator times numerator, so 3, denominator times denominator over 10. And I'm done. Right, so this simplifies to be this, much easier. Okay, so if it's a fraction, you just do the fractions like normal. Yes?
If the exponents, like fraction,
Yep.
is like, for example, let's say it was like 2 over 4.
Yep.
Could you simplify the exponent?
Yes,
to some fraction?
for sure. So yeah, if the exponent is 2 over 4, definitely make that 1/2, because then you have lowest, smaller, lowest, yeah, for sure. Always, always simplify, yeah. So if it's a 2 over 4, definitely make it a 1/2, etc. Yeah, good. Okay, good for those. Let's keep going. So again, this one's got no fractions, but it's got negatives. We can do this. So again, you've got different choices. I can subtract, or I can do the shifting. What I don't want is fractions on a fraction. So, but that's not going to happen because we're not going to do that. So I can't subtract because look, that's an x, a y, and a z. Oh, I have no choice in this one, right? No choice. So I'm going to just shift. So this guy here is going to shift to the bottom, and this one's going to shift to the top. Do not grab the 2. The 2 is not -3. The 2 is sitting by itself with the 1, right? It's by itself. Just say it's attached, but it's not part of it. Same with the 5. Everyone grabs the 5 and tosses it on top. What's the exponent of the 5? 1. It's not a negative. Everyone feels like grabbing it. It's kind of like when you get in trouble and you grab the person next to you. Don't. No. It's like, well, them too. No, nope. That innocently sitting there with an exponent of 1. Innocently sitting there with an exponent of 1. Not moving. Do not move. Only this. Not the y either. Okay, don't move everything. So 2 stays where it is, right? Y stays where it is. 5 stays where it is. Does that make sense? So leave them alone. They have an exponent of 1. The ones that move our x comes down here to become 3, and z will go up here to become 2. Can I simplify anything else? Nothing, and I'm done. Easier. Try it again. I vary between a few easy ones and harder ones, right? So you can go back and forth. We know we're not going to get thrown off. Here, can I do anything inside the B first? The bracket, B for bracket? Nothing. Do I have to change that to 1 over n here? Not yet. That's the last step. So notice I'm doing the flipping thing at the very end. I don't do the flip, right? I don't do reciprocal. I'm going to do the power exponent laws first. Because look, if you multiply, I'm going to get rid of that negative and create another negative here. So might as well do the exponent laws and then do the reciprocal stuff after. Okay, otherwise you double your work and it becomes like more places to make a mistake. So here, I'm going to get m to the negative 3 and n to the positive 2. So now, to fix my answer, remember I said answer positive. So answer with positive exponents. So here, answer with positive exponents. Again, fix that answer. The m goes to the bottom. So this one moves, and this one stays where it is. So you're going to go n squared stays where it is, and the m moves to the bottom like this. I do not want this. Okay, not that. They're the same answer, but why have the extra 1 there? Why can't you just put the n on top? Okay, same answer, you'll lose a half mark because bad form. Right? It's like you're writing it separate when you could just put the n on top. Okay, so don't do this. Yes?
Are you allowed to do it? Well, like when I did it, I first thought of doing one, like the first part being 1 over m3 and negative 2, and then I just moved the n up.
Yeah. So you can do it. Yeah. So that's why. So there's always going to be kind of 2 orders with these exponent laws. So you did the 1 over first and then brought it up. Yeah. Perfect. Yep. Yep. Totally good. Yep. Exactly. So for all of these, yeah, there's always going to be kind of this 2 different method. You do this one or this one, and you're going to have, yeah, so a lot of these is 2. Sometimes there's 3 different ways. Yeah, for sure. So you can do 1 over and then just move the n squared up. Okay, good. Next one. This one. So you can see right away there'll be fractions. Don't be afraid of fractions. Fractions are fun. Fractions. Yay. Okay, so as soon as you see that, I like to change it to fraction form instead of having the root there. The root with the fraction form is distracting to me because I don't know what I'm subtracting. So I like them all to be in the same form. So I'm going to switch them all to fraction form. So this one here, 16. I put the equals here in your line so you can center it. Let me do this first. Okay. 16, a to the 2/3. Okay, don't write too small so you can't read your own writing. Here, I'm doing the square root of 4 and a. The square root of 4 is just 2. You can go ahead and do that. You don't have to save that and for anything else, just do 2. The a, square root of a, is 1/2. So if you can calculate the numbers, so see how I'm mixing it up now? We've got numbers like we did last section, and we have variables. So that's why we've got the variables and numbers mixed up together. But the square root of 4 is still just 2. Is that a question? Okay.
No, I did it differently.
Okay.
I did 4a, and then in the bracket 1 over 2, and then the next step I did.
Yep, and then you brought it in. Yeah, perfect. Yeah, you can put the 1 over 2 outside and then bring it in the next one. Yeah, so same, good. And then 8a, just leave it alone. So we should get up to here. Then all of this is multiplication. So again, exponent laws. So exponent laws means when we have exponents, we're going to add these guys here, right? So we're going to take these 2 here, and we're going to add those. But what do we do with the numbers? If we have 16 times 2. Yep. Yep. Let's see. So no brackets. Would that look okay? I'm just 16a to the 2/3 and then 2a to the 1/2. Yep, that would be okay. It's just a little funny looking because you get a number with a number. Yeah, but that's okay. Yeah. Yeah, so the question was brackets. That would be okay. Make sure that you don't get confused that that's like a 32 or something like that. Yeah, and then next question, next part here, I'm going to put those two together anyway. Yes, yeah, so that's okay without brackets. Here, so then, yep, so that's why. So we would gather the numbers in front, like why leave them together at the back? So we're going to make this 32 now, the 16 and the 2. And then the A, I'm getting A to the 2/3. So again, do this on the side. I don't need to see this. So you're going to go 2/3 plus 1/2, right? So 2/3 plus 1/2, I'm going to get the lowest common, so 3, 3, and then I'm going to get this, so it'll be 4 plus 3, so 7/6. Stop me if I'm wrong, we're good? 7/6. Okay, so 7/6, and then I put that over there. Okay, and again, you don't have to show me this bubble. That's my bubble of knowledge. That's your brain doing it on the side, right? On the rough paper, put the 7/6. I'll look for that. And I still have 8A on the bottom. Haven't done anything there. So I always clean up the top as much as I can, then the bottom. And then now I can't do anything more in the numerator. Denominator is already set. And then now, again, make sure you're treating this like separate questions. We talked about this before in chapter 2 when I said the numbers in front are just numbers. 32 divided by 8 is just 4, right? So just put 4. So it's still just a number. So treat the numbers like numbers. If I can reduce it, I reduce it. If it's a fraction, I reduce it, whichever. So you treat the numbers like its own separate question. And then here, what do I do for the A? This is, yeah.
7/6 minus 6.
That's it. So we're going to do 7/6 minus 1, which is, right? So 6. I don't like the bracket. So 6. 7/6, which is going to be 1/6, yes? And again, if you can do it faster, that's okay. So 7 minus 6, so it'll be 1/6, and we're done. That's it. Okay, so a lot of the questions look really intimidating, but I just break it up. So I do the numerator first, clear that up, finish the denominator, then do the subtraction. Okay, so no matter how long, yes, yeah. How long it is, we just try to break it down. So same with this one. Looks overwhelming because there's a numerator and denominator. Just treat it separately. So I'm going to do all the numerator, all the denominator, and then bring them together in the next step. So here. Again, just looking at the top, each one of these gets their own 1/3. So imagine that this one has its own power of 1. This one, okay, and that's multiplication. Same thing with this one, so it'll be 16 has a 1, so that's going to be multiply, 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 and that's multiplication again. Okay, so what is the third root of 27? Do you have it memorized now? Yep, 3, right? Again, when you finish the homework, you'll be like, yeah, I got that one. 3 times 3 times 3, okay? A, what's negative 3 times 1/3? If you want, you can do it on the side, right? So we'd go negative 3 times 1/3, right? So anytime you want to do the fractions on the side, top times top, bottom times bottom, I get negative 3/3, which is negative 1, right? So that's negative 1. The B, can you do 12 times 1/3? Which is just 4, yes. And again, if you need to do it on the side, do it on the side, right? And then just drag it over. Right, so if you're like, not the fractions I have to do slower, do it on the side. How about 16 to the 1/2? Yeah, square root. Square root of 16 is 4. How about A, negative 8 to the 1/2? Negative 4. Right? What about 12 times 1/2? 6. And look at that. Such an intimidating question is already looking so much better. Then we have the same scenario that we started with at the beginning of the page. So it's up to you, right? So now we've done a few of them. It's up to you. You can do the subtraction thing, or you can do the shifting. It's up to you, right? We've simplified as much as we could. The top is simplified, the denominator is simplified, numerator, denominator, and then all we're going to do is the shift or subtraction. It's whichever one. They're both good, whichever one you want to do. Do you want to do the shift or the subtraction? Shift them up and down. So shift this one up and down, or did you do subtraction? Shift? Okay, let's do a shift. And we're shifting So the negatives move around. So that means these two move. Only those two. Don't grab the 3 and don't grab the 4. Those guys don't have the exponent. So we're going to do, so I'm keeping the 3 and 4 alone, right? I'm going to leave the b to the 4 and the b to the 6 there. It doesn't matter the order, right? Because we're going to add them anyway. The a goes down here, and the a to the 4 goes up there. Okay? But then for this one, I gave you a different scenario. I can't add them. So it's different than the top of the page. So you will have to do the subtraction anyway. So I mixed it up a bit. Does that make sense? So the first one I gave you, we were able to add the 2, and here, look, we can't. So we're going to do it again, and we're going to do subtraction. So we're going to have to do a minus. So there'll be 4 minus the invisible 1, right? So we're going to go 3 over 4. So I mixed it up a little, okay? But we're still okay? So you have to do the variable a first. So we're going to go a, 4 minus 1, so 3. So that's 4 minus 1. And for the b, 4 minus 6. Uh-oh. What do I get there? Minus 2. So then that is now minus again. How could I have done this faster? I could have done it like this, and I'll show you again with these rules. Okay? With these rules, if you saw that there was more 6s on the bottom, you could have said, but I took away the 4 from here and crossed it off and left 2 on the bottom. Just like we did when we were crossing things off in chapter 2 with the factors. So you could have said, I have 4 here, I have 6 here, I can cross off and leave 2 on the bottom. And here I have 1 here and 4, I leave 3 on the top. Okay, and again, that's okay as well. So multiple ways to answer it as long as you're following the laws.
So when you do like a subtraction from the numerator to the denominator, like b4
Yes.
minus b6,
Yes.
it's always, I know it's negative, but does it automatically go to the numerator?
Yes. Whenever we do the subtraction of the top to the bottom, we put it on the numerator. Yes.
Okay.
Exactly. Yep. So that's why people are like, can I just move it? Yeah. No, it's the rule. So if you go 4 minus 1, the a to the 3 goes up here. If we do 4 minus 6, it's a b to the negative 2 on the top. And then you move it. Yes. Yeah. Okay. So anytime we do subtraction, yep, it goes to the top. So that's why I had to put that there, because I did 4 minus 6, so it's b to the negative. Then you move it to the bottom. Some people go, wait, if I see there's 4 and 6, can I just say I took away 4 here and I left 2 on the bottom? And yeah, it's the same thing. Okay, any other questions?